Hi everyone, and welcome to lesson 13, which is the quadratic formula lesson. So today we're going to learn how to use the quadratic formula, and this is a formula that could be used to find the solutions of any quadratic equation. So first we're just going to do kind of just a small review here for the do now. What are the zeros of f of x equals x squared plus 3x plus 2? So remember when they want us to find the zeros, we're solving for x. We want those points on the x-axis where that parabola hits, the points where the parabola hits the x-axis. That's what we're solving for. Okay, so the first thing we want to do is we want to rewrite the function. And we want to set it equal to 0 because we're finding the zeros where the y values equal to 0. That's what we want to do. So now you want to think about what method should we use. It doesn't tell us whether to use product sum, completing the square, whatever we've learned so far. So let's first try product sum because that's the easiest here. So remember you want to find factors of c that also add to your b value. So our c value here is 2. So the only factors of 2 are 1 in itself. And it turns out that 1 plus 2 gives us our b value, which is 3. So we're going to break this down into the product of two binomials. So it's going to be x plus 2 times x plus 1 equals to 0. All right, next, if you recall, now that we factored the trinomial, we're going to solve for x. So we're going to set each binomial equal to 0 and solve. So this is the really simple part. X plus 2 equals 0. X plus 1 equals to 0. Here we're going to subtract 2 on both sides. X equals to negative 2. And here we're going to subtract 1 on both sides. And x equals to negative 1. Okay, now if we go into Desmos quickly, and I type this in, okay, I'm going to go to desmos.com, and I'm going to type in our function, so we can see, just to check, that is our 0, so x squared plus 3x plus 2, so x squared plus 3x plus 2. And this is our graph, and you can see negative 2, 0 is 1, 0, and negative 1, 0 is the other solution. So we were correct. Okay, so we're gonna move on to, and I'm gonna introduce to you the quadratic formula. So what is a special formula we can use to solve all quadratics? So that is this is the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac divided by 2a. So it looks complicated, but it's not that bad, okay? And I'm going to do 2 examples with you. The easy part is the substituting the values, and maybe the more difficult part is actually reducing it to figure out the x values, but it is doable, and I will show you an easy way to do it. So when can we use the quadratic formula? We can use it for any quadratic equation. So if you had to solve for the roots of any quadratic equation that they give you, you can use this formula. Okay? In order to solve for the roots. Slash zeros. Okay? Slash solutions, right? They could be, has many names. All right, so let's take a look at how this formula is used. So I'm going to go to the next page of the activity guide, and we're going to do 2 examples together. So we're going to use the same example from the do now, We already know the answer is -2 and -1, but we're going to check using the quadratic formula. So I put it for you on the top, and the easiest way to go about it first is to first identify your A, B, and C values. So for the first one, our A value is the number, the coefficient of x squared. So that's at invisible 1. B is a coefficient of the middle term, which is 3. And C is the constant at the end, which is 2. So next you're going to substitute A, B, and C into the quadratic formula. So you don't have to memorize this formula. You just need to know how to identify the A, B, and C values and just substitute the values into the correct place in the formula. So first it's -b. So the b value we're going to put first here is 3. Then we're substituting all the values in their place in the formula. So it's b squared. So we're going to put 3 here, minus 4 times a, which is 1, times c, which is 2, over 2 times a, and we know a is 1. So you're simply just putting all the values in the correct place. Next thing you want to do is you want to reduce this and solve for x. So what you want to do first is you want to first reduce and simplify what's under the square root sign or the radical sign. So this becomes -3 plus or minus. Remember, you get 2 answers when you take the square root. So that's why we have this plus or minus. Okay, now 3 squared. 3 to the second power is 9. And now here we have 4 times 1 times 2. So I'm going to keep that minus, and 4 times 1 times 2 is 8. Divided by 2 times 1 is 2. Okay? Now, let's continue to reduce this further. I'm bringing whatever we didn't touch down. Under the square root sign, we have 9 minus 8, which is 1. And we still have this whole thing divided by 2. And now we're getting very close to our answer. So we have x equals -3 plus or minus the square root of 1, if you use your calculator, if you know in your head, 1 times 1 is 1. So the square root of 1 is 1. And this is all divided by 2. So at this point, we got rid of the radical sign or the square root sign, okay? What we want to do now is actually solve for the values of x. So one answer is going to be -3 plus 1 divided by 2, and one's going to be -3 minus 1 divided by 2. So here's where we're going to split this into 2 equations. So one's going to be x equals -3 plus 1 divided by 2, and the other solution is going to be -3 minus 1 divided by 2. So this becomes -3 plus 1 is -2 divided by 2, which is -1. So that's one solution, which we got in the do now. And -3 minus 1 is -4 divided by 2, which is -2. And that is our other solution. So this is how we would use the quadratic equation to solve for our roots, solutions, zeros, whatever you like to call it. All right, let's do our next example. 2x squared plus 5x plus 1. We want to solve for the roots using the quadratic formula. So first we're going to identify a, b, and c. So a is the coefficient of x squared, which is 2. B is the coefficient of the middle term, which is 5. And c is that constant at the end, which is 1. Okay, so I'm just going to pull it up a little bit so you can follow with me to substitute. So it's -b, so we're going to replace 5 here for b. And b also under the radical, the first number under the square root sign, so we're going to put here 5 minus 4 times a is 2. Then times c at the end here, which is 1, over 2 times a, which we know is 2. Okay, so at this point, we're going to continue reducing this. So like we did in the other example, we're going to first work on reducing what's under the radical sign. So 5 to the second power is 25. And then in the calculator, you can do 4 times 2 times 1, which is 8. And that is all divided by 2 times 2, which is 4. Okay? Next, we're going to keep reducing what's underneath the square root sign. So we have 25 minus 8 under the square root sign, which is 17. Okay? And that is all divided by 4. So if you do the square root of 17 on your calculator, you're going to see it's a crazy irrational number. It's not a perfect square, so it does not break down easily. Okay, so since we cannot break down the square root of 17 any further, this is going to be our answer. Okay, so x equals -5 plus or minus the square root of 17 over 4. Not all, there will be other times in the next video you'll see we will be able to reduce this further, but for this instance, square root of 17 cannot be further reduced. It's not a perfect square and it's a prime number. Therefore, it cannot be simplified any further. And now you're going to work on a few practice problems, and I'll see you in a few days for the next lesson. Have a great day.